Hey, this is Ken with the Black and Yellow Garage. I know a lot of y'all don't like this, where we build things and don't show you everything. But this is Seth's FA20 out of his 2013 Scion FRS. So, recap, what he had was a bearing that spun, and there was nothing left of the bearing on the rod. So we had to short block it. Short block came, and I sent the heads to the machine shop. The machinist said that they were just a little warped, and he made them flat again. And they held vacuum. His impression was that they looked like they were brand spanking new, other than the little warpage. So we came to the building it back, and I went to Toyota because this thing needed an update on the valve springs that they offer for free. But they told me to go ahead and build it back up. It had to have a 1,500 miles on it, and then they would go and do the update on the springs. Okay, so last night I came in and built it back up to this point. So we just want to give a few tips that I learned from doing this after watching a couple of videos on YouTube, and hopefully this will save somebody some trouble. Just helpful. I don't claim to be an expert at building this motor. This is my first one, so this is just a rundown of some of the things that I saw in the videos that I would probably make a correction to, just from my experience. So they all want you to start on the left hand side, which is this side. So that end gets pointed up, and in order to build it back up from a short block, all the RTV has to come off of the surfaces. So what I used to remove the majority of the RTV was a round wooden dowel, probably an 1/8 of an inch round. Just wore my thumb out putting pressure on the same spot. Others use hot water, but I didn't break down the cam assemblies. I left it all together. So, I didn't see the point of going in and redoing that, because, if there is damage done from the metal floating around in here, it is what it is, other than buying a new motor. So we did clean out the passages as best we could. There was screens for the flow to the cam phasers that we just cleaned them out. I figured anything that got past that was just going to be so small, and the car was running when it came in, so maybe the debris might just get caught up in the oil filter later on. We'll just change oil filters regularly, just put a little bit of time on it, change filter, change filter, change the filter. Okay, I've done that before in the past, and motors are still running. So here's the tips that I have. The build process in the head is they want you to lay a little line of RTV on the head gasket. I think it is on this end here. You can see, and the line went this way on this side, and well, I'm not doing a very good job of this. Let's see if I can do this a little bit better. Went across the gasket this way for the head gasket, on both sides of the head gasket. So I kind of laid it off to the side and laid a bead on where it needed to go, and then flipped it over and laid the bead. So here and on the other side, I really don't understand the purpose of that, but we did it according to the specs that they want it built up that way. All right, so I'm just going to go ahead and recommend everybody do that. Every other head gasket, just bolt it down. But the difference here on this engine from what I've done, according to their specs, is they want you to torque down following the sequence, all of the bolt heads to something like 14.8 foot-pounds. and then go up to something like 73 and torque according to the sequence, and then undo the torque by reversing the bolt 360 degrees. So everything's back to being loose. I think all you did was squish the gasket down some, and then you're going to go back and torque the head to 14, and then I believe it was something like 73, maybe 71, and then in the sequence for all the bolts, they get torqued 100 degrees, and I did go the extra dollar to buy the snap-on with the angle adjustment on it, so we don't have to use all the goofy other tools that you have to bolt down. Both of mine have the this is the inch-pound torque wrench, then they overlap, so there's no need to have the middle 3/8 one. This is a 1/4 inch. So degrees on both of these, and the torque was 100 degrees on the first go around after you got to the 73, I believe. So it went 14.4, 73, loosen everything, 360 degrees, back up to 14.4, 31, 100 degrees, and then the two center bolts got another 100 degrees, and then the outer bolts got another 50 degrees in their sequence. Okay, and that took care of the head. All right, now the cam assemblies went got their RTV put on them, and in the videos that I watched, there's a young man, he smeared RTV over all of the machine surfaces. I only did it on the perimeter of the assembly, and left all the machine surfaces inside free of RTV. And the reason I did that is I'll give you an example. Inside this engine there is a surface here behind this tensioner, and the like one is down here, and that's a machine surface. So when you have a machine surface and a machine surface carrying oil like that, I don't think you're going to need RTV. Okay, so I'm not putting RTV on those surfaces, only the perimeter around the sub-assemblies. Okay, and I'll give you an update and see how this goes, but as far as I know, that's the only area you need to do. Cover where it could leak outside of the engine. All right, and then with the sub-assembly, everything got torqued down to 13.3 foot-pounds in the sequence. And then, this is the odd part, you had to start in the middle and undo the bolts in a sequence for loosening, and then retighten them in a different sequence. So they wanted you to do that for the middle, and then the back of the motor, and then the front of the motor. So you were loosening in one sequence and then tightening in a different sequence, other than the original sequence when you tighten them down to 13.3 the first time. So seems like a lot of goofiness, but it may be a purpose to it, I don't know. So then we moved on to the valve cover gasket, and Mitchell and I guess Subaru want you to put RTV all the way across here, all the way across the humps. Okay, like that. And my school is put it in the corners at the base of the humps. And the reason I just did that is because of the 1,500 mile thing from Toyota. We don't want them to have to rip all that off. If this is leaking up for 1,500 miles, we'll just keep piling oil in it. I don't think it's going to leak that bad. That's the purpose of a gasket. So we'll let them do the extra RTV if they feel it necessary at that point when it goes in for the update. We'll see how it responds, once we get it cranked up. Okay, so after that, of course, you're doing this, putting the head on and doing those bolts, and then flipping the motor over and doing those. So while you have the same torque wrench, same tool, you're just doing one side then the other. So when you get to the point where you are putting the lifter adjustments and the rockers and the lifter itself, I think I said in my other video that this is how I did it. When it's up on top like this is the front of the motor. So I have lifters and everything from this side, which went into my egg crate this way, and then this bank on the bottom went on this side, and then when they went back together, just a reverse order. Keep track of everything. Even the location of your bolts is important for the heads, because the two middle ones get a different torque. They get that extra 100 and the outer ones get the 50. I didn't really pay too much attention to that until I watched another video from the guys who build the race engines, and they showed the center bolts being a different color than the outer bolts, and all of the bolts were black. So I'm hoping that made no difference in this one, that the bolts would be able to withstand the extra torque on the middle, and you know, just didn't apply that extra torque on the outside. Okay, so that goes for the torque sequence on the valve cover. All right, and then this morning I came back in and I was going to go ahead and start the timing, because I gave up last night when I put the cam assemblies in. They were in the relax mode, which meant that all the valves were closed. So the lobes were all pointing up, and I could oscillate the the cam a certain degree. But as far as the triangle was not pointed down in this direction. It should have been. Okay, so I had to rotate this intake cam, and I didn't want it to snap back on me, but actually what ended up happening is they want you to use a specialty tool, but I just used a flat bar, drilled a hole in it, put a bolt through it. So I had one, and then, you know, did my measurement and did the hole in the other one, and then I had the tool to rotate it where it couldn't snap if it rolled over the top of the lobe on the cam. But all it did was rotate it to the peak of the lobe, and right now both of the valves are open, and the piston was at that time all the way to the bottom on that cylinder, in order to get the chain with the dark link onto its perspective marking. So you can see that's where I have my mark off of the key, and it is lined up with the dark link. And on the top we have, on the intake, we have our pink key link, and it lines up with the line. And then on the bottom we have our pink one, and it lines up. So right now the guides are on. The tensioner was drenched in a bag of oil to get the air out of the majority of the air out. And then I waited about 45 minutes and you know, made sure that I was moving them around, all the bubbles running up, stopped coming. Then I bolted it up. Still have yet to put the torque specs on this, but I did go ahead and pull the grenade pin, and it locked down nice. Okay, and here's the difference from the other videos that I've seen out there. I have yet to see this tip for doing the right hand side. The video I showed, once the fellas had the chain on the left side, they rotated the crank, and I heard a big old snap. Didn't like that. They didn't like that. But the links won't match up. I think they did 2 revolutions on it to get it to back to where this crank timing mark was, where they wanted it. And of course on this side, these are free spinning to where they're lining up. The triangles are face to face on this one. You know, they're going to the center. Oh, I'm sorry, going to the center down here. Okay, and this one will be easy to set the chain on. All we have to do is get the mark down here onto this one. But here's the tip. In Mitchell, it says to rotate the engine counterclockwise approximately 135 degrees. So if you can see Don't know. There's my mark right here where my finger is. Okay, so that's a little bit more than 90 degrees. And I guess if I'm going to go ahead and rotate counterclockwise backwards slowly, all right, then we'll put it to where they're saying the keyway is pointed at the 6 o'clock position. And then you would be able to get all the timing marks lined up for the right hand side, so that later on when you rotate back, all of the links will be, you know, the pink links will be where they need to be and the black links will be where they need to be. Don't understand it exactly, you know. I don't know if this side's going to line back up, but this side will. And I guess you could go back and forth and see that it is lining up, because once you rotate it around, these pink links will not be coming around to the same mark on the next rotations. It takes a lot of rotations to get them to all line back up again. Okay, so the tip is to rotate backwards rather than forwards. And again, I heard that nice snap, and I would like to know if there was anything going on that other video that I watched. So we're going to go ahead and let me think if there's anything else. Did note that the knock sensors have to be oriented in 45 degrees here, and I think it was 15 degrees here on this side, the left side. So even in my making of the previous videos and taking pictures, I had the heads off and everything, and I had bolts up in here, and where they, you know, I might have taken them out and put them somewhere, but have to catch up with a couple, because I think I'm missing two that should be already here. And bag and tag, when you're taking apart, there's a bag with a tag, there's a tray, but all those are related to that in the underside of the car. This is all the timing cover bolts, you know, water inlet, pretty easy. And as you get less and less bolts, it's just easier to find out where they lived. Okay, you know, because it's been a while since I took it apart. I don't have a great memory, so we do what we can, and I think this motor will be a success once it's all done. One of the issues that I had with this, because, you know, it comes in when somebody else has worked on it, it looked as though someone else had been in here before. They might have even short blocked it before, and I want to explain what I think possibly went wrong with this build. And that is the fact that the oil pan, the lower oil pan, has two round, from what I gather, are pickup tubes. And the tubes go upwards towards the top of the pan, and then they go through, the tubes go through something like a washer, and then, you know, all that is welded into the pan. Then there's supposed to be a gasket between that flat washer area, and the tubes actually protrude above the washer. And go into the block a little bit. So the on the metal washer that's there, there should be gaskets, and in the teardown there were no rubber gaskets. So I can only assume that those two tubes are coming down at an angle like this to the bottom, and then there's a main tube that comes from the middle down. But I don't care, even if you had the main tube picking up here, and up about this level here is where the other tubes are, and then the flat washers here mating up with the bottom of the upper oil pan. If that is not sealed, you're sucking air. If you're sucking air, you're frothing oil. If you're frothing oil, you're gonna spin a bearing. The lubrication of the engine just is not there when you have bubbles in the oil. Damage will result. So I can assume that that probably is what killed this engine, aside from the sloppy RTV slathering all over this previous build. And I'm going to go over to the bench, and what I have here is the fuel rail crossover tube for the coolant. These are where the injectors live, and my injectors, a couple of them, when I disassembled it, stayed in the block. So the way this works is there is a little plastic piece, and it's kind of beveled because there's a bevel at the top of this. So it goes on. All right. And then an O-ring, big fat O-ring, supposed to go on. And then at the tip of this, there should be what Toyota and Subaru said is a blue clip. Okay. So none of the injectors had the blue clip. And I said, well, possibly they're in the hole. And they're not in the hole. Nothing in there rattling around. So obviously someone has been in there and on the last build lost those, because I even lost one of these plastic pieces. When I did the tear down, I saw it. Usually anything on my floor I pick up and I put in a tray. Just never know what you might not see. So I've since cleaned the garage. I might have blown one of these outside. I'm not going to look for it. It's, you know, pennies or $1 at the dealership. They've got one coming tomorrow. All the blue tips are coming tomorrow, and we'll continue with the build. But those tips were not there. Hey, I'm going to make it right. It's not leaving my shop without all the proper parts on it. Okay, so tomorrow, once everything's here, we'll build it back up, put it in the car. It doesn't take that long to put it back in the car. At most 2 hours to put everything back in the car. I think all of the accessories that go on there could take maybe 45 minutes to put everything on. And I think today I will have put the timing chain on the right side and sealed up the timing cover. Okay, so then everything tomorrow is just the accessories and dropping it in the car. All right, so we'll give you an update, let you know how things go. Okay, thanks for watching. Bye bye.